Hello everyone, my name is Abhishek Rai. I am doing PhD from Department of Civil Engineering, IIT Roorkee. Today I am presenting our work on augmented reality in education and remote sensing. The content of this presentation are as follows. We will first go through an introduction about augmented reality and AR in education. Then we will move on to the data and methodology used, followed by result and conclusion. Augmented reality is a variant of virtual reality technology which allows to see the virtual content overlaid on top of the real environment such that they appear to coexist, unlike VR in which virtual content replaces the real environment. In this article, we have proposed a method to utilize AR for visualizing remote sensing data for the purpose of education using visual and auditory methods. This method of reality-based education is the future of the education system. Augmented reality has been around for more than 4 decades now. Its enabling technologies have flourished to a stage now where AR can be utilized in a form of technology of the future, which enables one to enhance their senses way beyond their natural behavior. It can enable us to digest the data in a way not thought of before. AR has entered the mainstream with the advent of Metaverse, Pokemon Go, and filters on the social media platforms. AR has been proved successful in improving education from traditional literacy. By supplementing the existing methods of visual and auditory modes of education with an interactive virtual environment superimposed over the real environment creates a significant improvement over traditional methods. Remote sensing data used for demo application was collected and categorized into these three groups: 2D, which consists of 2D image data like each band information from multispectral image, RGB composite, false color composite, thermal band, etc. 2.5D data is TEM, which consists of height information but has a value assigned to each pixel. 3D data is point cloud data from LiDAR sensor. Categorizing the data into these groups helps in handling of each data types in AR environment. AR works on the method of detecting unique features on the image and then matching those features with features detected in subsequent frames to derive the camera pose. The camera pose thus acquired is used to overlay 3D content over the camera feed. Continuously updating the pose as per the movement of the camera adds realism to the whole scene, which enables the user to perceive virtual objects acting as the real object in real environment. The images at stages 5, 6, 7, and 8 show each step from feature identification to horizontal plane detection and then to interaction by placing virtual content over the ground. This is a video demo of application named RSAR, Remote Sensing in Augmented Reality. You can request through Google Form to access the application installation file or by scanning the QR code. Coming to this demo, starting the application will show you a camera feed which is trying to detect horizontal surfaces. Once the horizontal surface is detected, you can tap to place virtual content. In this case, this first scene is virtual classroom with board having posters to teach about remote sensing. There are animated objects as well as auditory
Remote
information to teach.
sensing is the measurement or acquisition of information from certain properties of an object or phenomenon by a recording system that is not in physical contact with the object or phenomenon under study. Remote sensing is a scientific discipline.
Somebody with a good animation skill can also add 3D avatars to teach as a teacher. In this next scene, details about remote sensing data are explored.
It is important to understand your tool. Knowing which type of scanner collected your imagery can help you better understand your data and how to work with it. There are two types of sensors commonly used for passive, optical, satellite imaging.
Coming to the third scene, which is very interesting, is a 3D point cloud of a portion of Department of Civil Engineering, IIT Roorkee, collected using TLS. This point cloud is classified into four classes, namely building, vegetation, man-made objects, and ground, and added to the scene for virtual walkthrough, which can also be used for various other applications such as site inspection. Last scene of this demo is about instrumentation in remote sensing. This scene shows a scaled model of Landsat 7. I conclude with the following remarks that AR can make learning more efficient and immersive. We developed an application to showcase remote sensing data using augmented reality for educational purposes. What we learn with pleasure, we never forget. A quote by Alfred Mercier perfectly summarizes the objective of this research. Thank you for listening.